if you want to study the relationship between people's wages or salaries and their levels of education, you might be worried about how to model such a relationship. You don't know whether you should fit a linear relationship or a quadratic or a cubic polynomial or a quartic polynomial or a logarithmic relationship or exponential one. You don't know. It's something you worry about. And also you worry about how to cater for all other factors that affect somebody's salary other than the level of education. Okay, so as you worry about that, you also worry about what we call the ceteris paribus, how you can isolate the effect of a particular variable, holding all other variables constant. So I was saying, well, for example, you all know, oh, there's some feedback. For example, we know that your experience in the labor market affects your salary, your level of education affects your salary, your smartness or ability affects your salary. So how do you isolate the effect of one particular variable is what we call the ceteris paribus issues. Okay. So as you worry about these issues, we say, well, regression analysis, which we define or explain to be the statistical technique that we use in studying the relationship between two or more variables. That regression analysis provides a platform for us to address the three main issues I mentioned, be the ceteris paribus, the functional form, and also how to control for all other factors. So we say a good place to start, because it's a quantitative technique, is to plot like a scatter plot of the two variables. In this example, this is about how much more about cartons of Coca-Cola a driver can deliver against the time. Okay, how much Coca-Cola is this person able to deliver in an hour or 30 minutes and so on.
Yo.
John Hansen, you are disturbing us. Mute yourself. That's the first thing you do when you join a Zoom. You check if you are muted or not.
I need take a pick up.
Okay. So you plot a scatter plot of the relationship and see. So we say, well, if you are lucky, you see something linear like this, then it suggests that, look, the relationships could be linear. Look at the scatter plot. It suggests, a good place to start is to check out a linear relationship between the two variables. So that's it. This is a quantitative or statistical technique. So you plot them, okay? And then, so this takes care of the functional forms. Okay, looks like this could be linear. Let me fit a linear model and see how it goes. If not, I can massage it and so on. Okay, so that's what regression analysis is all about, studying the relationship between two variables. Statistical technique is quantitative in nature, and we want to know how one variable affects the other and so on. Okay, so it's used widely, and most of the consultants work we do border on regression analysis, because policymakers are always interested in how this affects that. How does free SHS affect core mathematics score? I will employ regression analysis, okay, because there's a variable called core mathematics score, and there's a variable called whether a student benefited from free SHS or not. And I want to study how they are related, okay? So as you think this relationship could be linear, well, a good place to start is to try a linear relationship to connect them. So I'm connecting Y and X in this particular way. Okay, if you attended wherever, secondary school, which you all did, or junior high school, or specifically in Ghana, we call something Y is equal to MX plus C. Equation of a straight line, Y is equal to MX plus C. where M is the gradient and C is the constant, something like that. So the highlighted portion looks like equation of a straight line. Y is equal to mx plus C. This is the C, the constant, and this is the slope, which is the M. So this is supposed to be the idea of that's supposed to be the idea of the straight line or the linear relationship I am beginning with. Okay, because when I plotted the data, it looks linear. Okay, and then the U here is supposed to control for or cater for all other things that affect Y that I do not know about. It's possible I know them, but I don't have data on them. So any other thing that is unobservable, any other thing that is a disturbance term or a random shocks are all captured by U. Okay, so equation 1 is called a simple linear regression model. Simple linear regression model. Okay, that is the name of equation 1, a simple linear regression model. So more annotation here. Y here is called a dependent variable because the dependent variable depends on the X. Y depends on X. If you change X, Y will change. So Y depends on X. It is also called explained. For example, I want to explain your salary using your level of education. So it is an explained variable. It is also called response variable. How does the harvest of maize, respond to fertilizer use? So the harvest is a response variable. It is also a dependent variable because the harvest depends on the fertilizer. It's also called predicted. I may want to predict your salary using your level of education. It's also called regressant. A lot of the time you may find me calling it dependent or the response variable. Okay. Beta 0 here, or beta 0, is called the intercept. I'll come back to that. And beta 1 is called the slope parameter. Okay. X is the independent variable or the explanatory variable or control variable or predictor variable or regressor. I'll mostly call it regressor. Okay, this is a regressor, this is a response variable, and so on. So if your regressor, this predictor variable, if it is 0, then beta 0, okay, is the level of Y. Think about it. If I set this to be 0, and this is usually assumed to have a mean of 0, so don't worry about it now. If I set this to 0, then we take beta 0. It's like the intercept, right? When X is 0, Y is assumed to be this, if it's actually a straight line. Okay, so the U here is supposed to, because there's usually no exact relationship between two variables, the U is supposed to capture for all other things that we do not know, or things we know but do not have data on. So it is called an error term. Okay, of course, if the relationship had been just this without the U, then it's like the Y is equal to mx plus C. That's a straight line which is predictable. Immediately you give me your X, I'll tell you your Y. If you give me the amount of fertilizer you used, I can tell you with certainty what your harvest will be. Okay, but unfortunately, there's usually no exact relationship between two variables. So you end up having an error term or a variable which is supposed to capture unobservables.
Hello.
It is also called a disturbance term.
Afternoon. Who is on the line?
Okay, please, no, those should all be muted. You should all be muted. Edward, be muted, please.
Isaac.
Edward, be muted. Victor, be muted. Okay.
Okay.
All right. So please, at least today, before we go, make sure you know how to describe everything here. So beta 0 is the intercept, how much y, the level of y or the average value of y if x is 0. And then x is our predictor, right? The regressor. Beta 1 here, beta 1 is how much x affect y, holding other things constant. Okay, we'll come back to all these things. But basically, henceforth, when I say response variable, I'm referring to y. When I say regressor, I'm referring to x, or the predictor variable. So in this formulation, I want to see how x impact y, or how x predict, or how changes in x affect changes in y. That is the issue here. And u is the error term or unobservables. Okay. The things that affect y that I do not know. Maybe I know, but I don't have data on it. It could also be in u. For example, if you ask people, or if you want to capture how smart people are, you don't have data on that. You know, the research you are doing requires you to capture how smart people are, but you have no way of knowing. All these transcript GPA are proxies, they are not too good. So that smartness variable becomes an unobserved variable, and all of them are thrown into the U. So that's why it's an error term, or a stochastic or disturbance term. It is disturbing the relationship. We usually make an assumption which may make sense later. We will assume the errors have mean 0 and unknown variance. So this is our error. All those things I said we do not know. We assume the mean is 0. Okay. That means that mean 0, and have you done all this expected value in the previous lectures? So once something is a random variable, did they define random variable in any of the lectures? Once something is a random variable, we are interested in its mean and its variance, the variability, how the variables are spread around the mean. So all this, you will make an assumption to be able to get desirable results. So we assume that this u here, the mean is 0. This is like the error term. The error term. If I'm supposed to predict a farmer's harvest, given his level of fertilizer use, I may overpredict by 10 bags of maize. It turns out that I may underpredict another farmer's own by 10 bags. So the first farmer I overpredicted, that was plus 10. Another farmer I underpredicted, minus 10. So plus 10 minus 10, they cancel out. So we assume that's the idea, that the u has a mean of 0. So if I overpredict at a point, I'm underpredicting, and they kind of cancel out. Okay. And then the variance, how the error term spreads around its mean is unknown, and it's sigma equals to sigma squared. Okay. That's the variance. Okay. And we usually assume the errors are uncorrelated. This is our technical stuff. They might not make sense to you right now. Okay. And we assume the errors are uncorrelated for a reason. I don't know if we ever get there, but it's an important, all these assumptions are important. Okay, these errors are unrelated. So the error, let me see the names of the people in this class. There is Kwame Peters, Prince Apetobo, Equia Arthur. So let's say Prince, Kwame, and Equia. Let's say I have this data. I have Equia's salary. I have Kwame's salary. I have Prince's salary. I have their levels of education. And I'm using U as the error term for each one of them. So I'm assuming, well, the error from Prince's model is not related to the error from Kwame's model, and so on. There is a way they can be related, because I'm your teacher. I am imparting knowledge, and you all have. So if your teacher, the one who taught you, has an impact on your salary, Then the error for the three of the students I just mentioned will be related because there's a teacher effect and they had a common teacher, which is me. So I'm just giving you an example where the error term could be correlated, okay? But we are saying that we usually assume the errors to be uncorrelated. It is convenient to view the regressor X as controlled by the data analyst and measured with negligible error, while the response Y is a random variable. This is supposed to simplify the analysis. Doc, could you please use the whiteboard? Yes, I was getting to that. Thank you. So, I like writing here. I'll underline stuffs. Okay. Where is this guy? So why right here? So the other error, sorry, the other assumption, this is what why is what? Why is harvest, the harvest. So we are thinking of, by the way, I'll be switching between the salary example and the harvest because some are easy, they make sense. Students can identify with. This is the harvest you might have. And this is what the amount of fertilizer that the farmer applied. Fertilizer. Fertilizer. Okay. I see some of you having issues with internet. You keep going and coming. Okay. So, folks, where is this guy? This assumption is what I want to explain. It is convenient to view the regressor as controlled by the data analyst and measured with negligible error, while the response Y is a random variable. Okay, that is, there's a probability distribution for Y at each possible value of X. I'm explaining all this all the way here. Where is this guy? Okay, so we are saying that we are making a simplified assumption. It makes the statistics easy and so on. So what is this simplified assumption? It says, well, before the farmer goes to the farm, he has planned ahead that, look, one of my farms will get 2 kilograms of fertilizer. One of them will get 4. One of the farms will get 5. One of the farms will get 6. So when he goes, he just he tell the boys, put 2 kg here, put 4 here, put 5 here, put 6 here. So that is the meaning of this. The guy has predetermined the X's already. This is X. X is the fertilizer, and this is Y. Because remember, we are predicting Y using X. So over here, you see, it is convenient to view the regressor X as controlled by the data analyst and measured with negligible error, while the response Y is a random variable. So the surprise element is only at the harvest stage. This is the only place there can be surprise, because this one is the later when the guy checks out the harvest. But as for X here, is controlled by the guy. That's a simplifying assumption that he has control over the X. He has decided X is under his control. So you will never see any farm with fertilizer equal to 3 because it wasn't planned. Okay, now we say, so there's no stochastic nature here. There's no surprise element here. It is here that they will say, the one that we put a 2 kilogram rather gave us 40 bags. And the one that we gave 4 kilogram rather gave 20. So this is where the probability comes in. The stochastic, the surprise element will now come here at the end of the season when the harvest comes. So as for this one, you cannot tell. Two people can put 2 kg fertilizer. They'll have different harvest. So that is the meaning of this guy. Yeah, there's a probability distribution for Y at each possible value of X. At each possible value, whether fertilizer is 2 kg, there could be varied harvest. So it creates a probability distribution at every level of X. Okay, so simplifying assumption, which says X is fixed. Okay. Over here, by the way, stop me anytime. Over here, I told you there's a beta 1 is a slope. How much X impacts Y? Okay. How much X impacts Y? It is the slope. Anything which is slope has root from calculus. So what is dy dx? Dy dx, dy dx, dy dx, dy dx is not different from, okay, when I say it's not different from, I mean equal to. I don't like to say equal to, it's not fancy enough. So dy dx is not different from beta 1
B1
plus du dx. So dy dx is not different, my dear friends, from beta 1 plus du dx. That is, but we assume that this guy is 0. Once we assume this guy is 0, okay, then dy dx is not different from beta 1. That is why we say beta 1 is a slope parameter. How does X influence Y? Is beta 1. Provided this thing here is 0. So we say to take care of this thing being 0, we say holding other things constant. Remember, if U is constant, it's not related to X. So du dx becomes 0. So it's important to say if X increases by 1 unit, Y will increase or change by beta 1, holding other things constant. That's the appropriate way of interpreting beta 1. If X increases by 1 unit, Y will change by beta 1, holding other things constant. Holding other things constant to take care of this guy. In other words, U and X are not related, and therefore du dx runs to 0. So,
hello, Prof.
Yes.
Oh, well, I don't know. You keep saying beta 1. What is beta 1? I don't know.
This is beta 1. Beta
That's
1.
beta,
Oh,
beta.
beta, huh? Okay.
Alpha, beta, gamma, beta.
Yes. This is the beta 1.
Dog is an American.
So that is it. Okay. All right. So there's a note here. By the way, I'm supposed to end at 3:30. So let me know, because I'm having fun right now. I don't know about you. Okay. So the simple linear regression model is rarely applicable in practice, but its discussion is useful, for kind of teaching purposes. Okay, why are we saying it's rarely applicable? Because rarely will you have such a model where only one variable is being used to predict another variable. Okay, in other words, for example, it's not only fertilizer that affects the yield or the harvest. So it is inadequate to have a model of just harvest and fertilizer. You may want to add rainfall, pesticides, and so on. Okay, so a model like this, which is called, I told you this is called simple linear regression model. Okay, why is it linear? It is linear because these parameters, the intercept beta 0 and the slope beta 1 are linear. That is why the model is called linear. When do we say something is linear? Okay, if this had been power 2, raised to the power 2, or square root, or exponent, then it would, or logarithmic, then it wouldn't be linear anymore. So that is what we mean by linear in the parameters. Yes. So when we say a model, a regression model is linear, we are saying linear in the parameters. Linear in the parameters. So if I were to write this e to the power, I hope you are familiar with the exponential function. E to the power beta 1.
Yes, sir.
Yes, the exponential function here. If I were to do this, it is no more linear in the parameters, and therefore it ceases to be a linear regression model. If I were to put this in the square root, it is no more linear in the parameters. So, but we can transform it to become linear. That's the point. But when I meet you somewhere on campus and I ask you, why is this linear? You will say, because it is linear in the parameters. In other words, even if I had put a square here, it still will qualify as a linear regression. I'm not talking about linearity in the regressor. This is a model which is quadratic in X, but my parameters beta 0, beta 1 are linear, and therefore it qualifies to be called a linear regression model. That is why it is called linear. But why is it simple, my dear friends? It is simple because there's only one regressor. It is simple because there's only one regressor. There is a message. Is it beta or beta? I am confused. My friend from computer science, okay, you can say beta. I will say beta because I schooled in America and I just came back on Monday, so I'm still in the mood. Okay. Anyway, what is here? Okay, so my dear friends, you have a
Hello,
solid
sir.
foundation now in simple regression. You know why it is simple, because there's only one regressor.
Hello, sir.
Why is it linear? Because it's linear in the parameters. Go for it, my brother. Go ahead.
Bro, somebody is asking a question.
Go ahead. Yeah.
Yes. So so with a linear regression model, what makes it linear is the beta naught and beta 1, but not the x.
Yes. If we call something a linear regression model, we are saying linear in parameters.
Parameters. Okay.
Yes.
Okay.
Yeah.
Okay.
Good question.
So it means if even the x, that is the x variable, is even squared, because the beta naught and the beta 1 is still in the linear form, it is still a linear regression.
That's right.
Okay. Okay. Well understood. Thank you.
Excellent. Good question. So I've been playing around these examples. Why the yield on fertilizer? This is the deficiency of linear regression, because the guy insists on keeping only fertilizer as the regressor. He has by default or automatically admitted all these relevant variables in the error term: rainfall, land quality, presence of parasite. These are variables that affect the yield. But if you insist on a simple regression, you can only admit one regressor. And by doing so, you have considered that any other relevant variable is dumped in the error term. And that's why we said simple regression is usually inadequate, because you are forced to throw away all these variables, which otherwise could have been in the model proper. So simple regression is usually not adequate. It is usually useful in experiment, if you are doing an experiment. Okay. Now, over here to the wage relation to education. Okay. The labor force participation, your labor force experience affects your wage. Your tenure, how long you've been with an employer, affects your wage, work ethic, intelligence. All this should have been controlled for. But if you insist on a simple regression, then you have admitted all this in the error term, which is not proper. It's not proper. Okay. A few things to note. A few things to note. Okay, I just got some good news from the US. Okay, so a few things to note. Regression equations are valid only over the region of the regressor. Regression equations are valid only over the region of the regressor variables contained in observed data. Oh, where is my whiteboard? Here, right here. Are you with me, folks? Matilda, your internet is not good, right? You keep going and coming. Who read going and coming this several seasons? Do stay on the baobab tree. All of you are WASI folks, you are not SSE. Okay. Let me read the slides again. Regression equations are valid only over the region of the regressor variables contained in the observed data. Regression equations are valid only over the region of the regressor variable contained in the data. So this is something you should take note that, look, you see that we have two, the regressors are 2, 4, 5, and 6. There's nothing like, for example, if somebody says, oh, sir, if I apply 100 kilogram of fertilizer, can you predict my harvest? Then I'll say, oh no, if you have 100 kg of fertilizer, my model doesn't have numbers that go up to 100. So I am limited. Okay, I can predict things in this neighborhood. If you say, oh, your fertilizer that you use is 3. As for 3, I have data in the neighborhood of 3. Even 7, I can predict things about 7, 8, 9. But if you say 20, 21, none of my data points actually went that far. So I am unable to make predictions. And so your regression is valid only in the range of the regressor variable, like this. That is it. Regression equations are valid only over the region of the regressor. So don't make misleading predictions. Please, can you see the slides? Can you still see? I was seeing some, so regression equations
Yes,
are
Doc,
valid.
can see.
Excellent. So it's a mistake people make. They build a model and then you are predicting outside what you had data. You don't have any data in 20s. If I don't have anything 11, 12, 13, 14, what I have is up to 6. So make predictions in that neighborhood. Importantly, regression model does not imply a cause and effect. This is so important to me. A regression model does not imply a cause and effect relationship between the variables, even though a strong empirical relationship might exist. Empirical, usually, if you hear empirical,
Hello, Doc.
yes.
Yes, thank you. In your earlier listing, the regression model relies on somehow the principle of linear equations.
Yes.
And taking from the background of extrapolation.
Yes.
How do you work out that in terms of the first point to take note of? If you cannot predict outside the region.
Okay.
How do we make,
thank you. Yes, you are welcome to predict outside. We are just saying don't go too far. That's my point.
No,
That's
okay.
my point. You are
Okay.
allowed to predict for sure. In fact, regression is used for prediction. So I'm saying that over here, if a farmer asks you that if he uses 20 kg of fertilizer, if he uses 20, can you predict his harvest for him? Then you tell him, I'm sorry, sir, my study didn't cover this wide range. But if you say 7, 8, 9, I can try, or 3. You see, because my data is in the neighborhood of what you are asking. You are welcome to make a prediction, but you are likely to fail big time. So your model is valid in this narrow range. That's it. You are allowed to make predictions, but don't go too far. That's the point. Does that make sense?
It does, Doc. Thank you.
This is
Sorry,
important to
a
me.
follow-up on that.
Go ahead, sir.
Yes, Doc. My understanding, I stand corrected, is, I mean, if you build a model, is the understanding is for the model to be able to predict for you future event or future parameters.
Yeah.
Assuming what you just shown, the fertilizer and the harvest. So if I have a model which you've picked those two values in there, ideally it's not the case that if you should give that model future, let's say this number of fertilizers, you're able to give you the number of harvests you're going to make per this fertilizer, and that your supply. Is that not the case? I mean, how does that juxtapose what you are saying that I should predict within the neighborhood?
Yes, so it's a good question. What I'm trying to say again, maybe I don't know if I can vary my answer, but for example, I don't want the meteorological service to tell me the weather forecast in January 2023. Their model cannot go that far. They only have data up to September. Today is 2nd. You have data up to 2nd September. Don't tell me anything about next January. Right? Just stay. You can tell me October, November, but you are overstretching it. Okay.
Okay, I get it. So the likelihood of getting something within 2023 is likely not to be true, but
because you don't have data in the neighborhood of 2023.
Very well. Very well.
So, but
Yes.
there are sophisticated
Hello, Doc.
models that update.
Recording.
Okay. There are other sophisticated models that update. So by the time you have December's data, you can do that January. You get it. So the model can be updated and so on. But for now, we are saying be careful how far you are making comments on. Does that help? Feel free and ask in another form if it wasn't clear. These are pretty good questions. Does that help? Is that all right? Hello?
Doc, yes, it is. It's okay for now.
So the model are built to be used for prediction, but it has limitations pretty much.
Okay. Doc, please also have a follow-up.
So let me add this. This escaped me.
On the second point, okay.
You must a way around it is to collect enough data. Remember, I was telling you I don't have data around 11, 12, 13. So why don't you interview more farmers so that you have a wider range? So that's one way around it. So if you can have plenty data covering from 1 kilogram of fertilizer to 1,000, then you don't have such a problem. So collect data of a varied range. Okay, go ahead, sir.
Yes, on the second point that you mentioned that the regression model does not imply cause and effect relationship. Does that mean that if you are doing a study and you want to see a cause and effect relationship between two variables, you can't use a regression model for that?
That is not what we mean. It's a very good question. Okay. So to establish causality, the relationship between a regression model does not imply a cause and effect relationship between the variables, even though a strong empirical relationship may exist. I was saying when you hear empirical, think of it as the opposite of theory, right? Like people say, I don't like theory things. People who say they don't like theory are likely, or somebody say, oh, I don't want theoretical evidence. I want something. I don't want theoretical evidence. They actually say they want empirical. Okay, so when you hear empirical, think of it as something practical or pertaining or stems from the use of data. Empirical evidence is supported with evidence as opposed to theory. So even though a strong statistical relationship may exist between fertilizer and the harvest, it doesn't mean fertilizer causes the yield. That is the point. Whenever you run a regression, you have not established a causal link between your Y and the X. You have shown, however, that they are linearly associated, or X predict Y. X predict Y. You are not claiming causality. A regression model is just a statistical tool. It's just a tool that you are using to estimate something. So how can such just a tool tell you something causes something? So I'll say more. To establish causality, what do you do? The relationship between the regressor and the response variable must have a basis outside the sample data. For example, the relationship may be suggested by theoretical considerations. So where is the whiteboard? We are saying that to claim, so if I know that education increases people's salaries, and I'm claiming education causes salaries to go up, and there is evidence to that, maybe theoretical evidence, something theory like, oh, when you take a stick close to somebody's eyes, he will blink his eyes. That is what there is evidence through theory. Theory has already, the theory says there are 5 sense, whatever, organs. That is theory. The organs, this is sensitive. This the eyes can see. If you take a stick close to the eye, it will respond. That is theory. And you can go and confirm using data. You sample 100 people, take a stick towards their eyes and see whether they will blink. So data has now been used to confirm such a theory. So without that theory existing already, that, oh, these 5 sense, whatever organs, this is how they are in theory, blah, blah, blah. Without that, you just getting up and touching somebody's eyes and they blinking, you can't actually generalize and say that whenever you touch people's eyes, they blink, and this is the reason. Okay, I'll speak more on this. So the point is there must be a theory or anecdotal evidence or theory. That is why my other colleague taught you hypothesis testing, because it is believed that when you sweep or when you pound fufu at night, something will happen to your grandfather. Anecdotal stories and evidence, you can confirm with data later on. So there must be something existing like your null hypothesis, which my colleagues taught you. And then you go and collect data. Your research topic is the alternate hypothesis. You are trying to refute what exists or not. Okay, so bottom line, the regression is just statistics, and you must have a reason why you are connecting X and Y already, probably from theory or what is believed to be. Then you say, okay, let me collect data and test using regression. Now, if you take the cost of President Nanado's shoe, assuming he changes his shoe every day, the cost of President Nanado's shoe and the cost of President Biden's breakfast, and you run a regression, you may find one of them, you may find them highly related or even related. Will you therefore say that the cost of a shoe in Ghana affect the president, causes the president of US salary to break fast to go up. Those are spurious relationships. Okay, but as for statistics, you are using Excel, so it may give you answer from the regression. So it will be misleading to just run a regression whenever and say X causes Y. My final point before any questions, one of these two equations can, my grandmother, who doesn't know anything in economics, statistics, my grandmother, who doesn't know anything in statistics, can tell me which of the two equations make sense. That is what I mean by a relationship existing anecdotally or in theory before you take it to the regression. So the one who asked that question, you must believe this relationship exists through theory already. Then in an attempt to confirm, you employ regression analysis. So regression analysis can aid you in confirming a causal relationship. But regression standalone does not imply causality. So let me write rainfall. Rainfall is here. The rainfall, amount of rainfall and the yield. Rainfall is not different. Rainfall is not different from beta 0 plus beta 1. The yield, the amount of harvest, or the yield. The amount of harvest or the yield. The amount of harvest or the yield. So my point is my grandmother can choose between these two equations I'm writing, even without statistics. That is the point. For there to be a causal link, the basis must exist outside statistics. What do I mean by the basis of that link must exist outside statistics? In other words, my grandmother will be able to tell, even without statistics, that equation 1 or 2 makes sense. Yield, I'm swapping them, and you should tell me which of them makes sense. You don't know anything in statistics, but you know one of them makes sense. The yield is not different from alpha 0 and alpha 1, the amount of rainfall. The yield you see is the amount of harvest or yield. The rainfall you see is the amount of rainfall. Which of these two relationships makes sense? You don't know anything in statistics, but one of them makes sense. You know something in statistics, but my grandmother, is that how we spell rainfall? It's looking odd to me because of spell checks nowadays.
You are right.
Thank you, sir. This is my error term W. Which of the two makes sense without statistics? You don't know. If somebody doesn't know statistics, you explain to her that is it the yield that causes, do changes in yield cause changes in rainfall? Equation 1. Equation 1 says changes in the harvest causes changes in rainfall. Equation 2 says changes in rainfall causes changes in yield. Which of them makes sense?
2.
It's 2. So it is 2 that has a basis outside statistics. So it has a basis either in theory or somehow through anecdotal evidence. Because of that, I will now want to confirm 2 and then go and collect data and come and run regression in an effort to confirm this relationship. But I can promise you that if you put number 1 in Microsoft Excel, you will get a result. Will you therefore say equation 1 is correct? No. So that's the point, that regression standalone does not imply cause and effect. It can, however, aid you in establishing the causal link. This is so important to me. Okay. I taught this to some members of parliament. They said on their WhatsApp group, one told me the WhatsApp group, one of the bosses said something causes something, and he told him that no, you can't claim this. And the guy is a senior party member and got angry. That can't you see? Can't you see this? So the MP told me that he remembered what I said and he told a senior party colleague. And because he's a senior man, he got angry on the page. So I think he said he apologized or something. But he believed that what I said is true. If something, so whenever you run a regression, you are saying, well, rainfall predicts changes in the yield. You cannot actually say it causes it. Okay. You cannot say free SHS causes improvement in core mathematics score. It's possible that it is the boarding school they are. Or it is possible that when parents are relieved of school fees, then they get peace of mind and they encourage their wards to learn harder. I'm telling you how people punch holes. So many things are going on. Okay, it's possible when parents are relieved of school fees, they are happy and they motivate their wards to study hard and the students do well. So if you want students to do well, let their parents be happy. That may include giving them free vacation to USA. So it may not necessarily be through the free SHS. So several things are going on. That is why regression is not enough. Okay. Maybe when you allow everybody to come to the secondary school for free, there are smart students who are poor, they are able to come. And when they come, they teach their colleagues during group study. So it may actually be the group study improving the performance, in which case you may not need a free SHS. You need to improve group study. So it is erroneous to say this causes that all the time. Be careful, because you haven't identified the causal link, even with a regression. A lot has to be done. So I went to a PhD defense at ESE. The guy said, oh, this because of this, he recommends free SHS. And me and a senior economist, they were laughing because so many things are going on. Okay. I believe that I don't even have a problem in schools under tree. A motivated teacher. If you're under tree, air is blowing. There's absolutely nothing wrong if it's not raining. I don't see anything wrong with being under a mango tree. It's not raining. There's a white blackboard. The teacher is paid salary well, he's motivated. I don't see anything wrong with school under tree. Absolutely. It's motivated teacher. Yeah, there's nothing wrong if it's not raining to be under a mango tree. Beautiful board and studying, provided there are no distractions from people selling farm milk, popu, and so on. So perhaps recommending the free thing may be what? Recommending higher salary. Okay, so my point is, whenever you run regression, yeah, just be careful. You are not really establishing causality. And by the way, when you use things like the impact of so and so on that, those of you who couch your research topics like that, impact of this, the determinants of this, you are actually claiming causality, and you may have a problem if there are smart people there. Okay. Doctor, when it comes to Ghana politics, there is no logical. Oh, okay, that's good. Yeah. So a lot of things are going on. So nowadays, I don't know any radio station or TV I will listen to, because a lot of things don't make sense that they discuss. Okay. But the City FM guys are able to meet some of my demands with interesting discussions. Okay. Any questions?
Hello, sir.
Yes.
Yes, your explanation is very, very clear. And thank you very much. But my follow-up question is, supposing you want to find a causal link between two variables, and it's a gray area, you don't have that pre-knowledge of this causal link. You use your regression to establish a link or establish a linear relationship variables. What else can you do to actually establish a causal link between these two variables?
Okay, I don't get you properly, but I will try and answer, depending on whether I understand the question. So sometimes students come to us with topics and we say, oh, this one is not doable, or this one doesn't make sense. And that is why, you see, you can't get up and study anything. So you can't, you say there's no precedent. You see, that's why all of you, your work are situated in the literature review.
Okay.
Yes, so it must be situated somehow. If you want a groundbreaking thing, then there still must be an anecdotal evidence, true storytelling. Otherwise, you can't say, well, I listened to a PhD defense at the economics department. The guy said he's studying insurance. He shared a souvenir questionnaire asking people, are you willing to buy insurance for your mobile money, assuming they steal the money from your wallet? And he asked them yes or no, blah, blah, blah. Are you willing to buy some insurance for your mobile money wallet? And he said, oh, when he was motivating his study, he said, oh, nobody has studied this in the literature, blah, blah, blah. Yes, because it doesn't make sense. It doesn't make sense. Why are you asking me whether I'm willing to protect my money? If MTN can't protect my money, MTN goes out of business. So go and sell the insurance to MTN, and MTN to guarantee me. And that's what Bank of Ghana do on our behalf. So GT Bank, blah, 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 must go and buy that insurance and cover us. You can't come and ask me question here whether I'm willing. I put money in your MTN and me, I should come and buy insurance. It doesn't make sense. Then I was laughing. The guy said, this study has not been studied in the literature and he's the first, blah, blah, blah. You see, because it doesn't make sense. So you can't study just anything. So if he is running a regression, it's a regression that doesn't make sense, but he got results and he got away with it. He's a lecturer somewhere in the country, not here. Okay. So does that answer your question? Let's come again.
Very well said. Thank you very much.
Excellent.
Yes, Doug. Sorry, just a follow-up on that. And I think our supervisors need to really help us in this light. For me, I'm still struggling to get
You are in which
my
program?
first year computer science.
Okay, computer science. Okay, computer science.
Yeah.
You can come and talk to me. I'm close to you. I'm in statistics.
Sure. And I think that is one thing that our supervisors really help us with, because as you rightly said, he has done something, it doesn't really make sense, but yes, he got some results and he has gotten away with it. Our supervisors really need to guide us and help us, not to do the work for us, but at least give guidance. This will make sense, this won't make sense. And if you do it this way, to rather, but I'm not casting this on my.
You have to do, like, are you doing a PhD full time or you are a lecturer here?
I'm a lecturer, but not in Legon.
Yes. So you have to, some of you have your research. You see, when I was teaching this MP, some of them, they are working in parliament, so they have ideas that already. Now, you can't sit down and create a research idea. No, you have to read the literature, read about 20 papers, current papers, 2020, read 2020. Okay, read 2020. Okay, beyond regression analysis, there are other ways. Some qualitative people are able to talk of causal link, but in a quantity way, we have to use, I'm answering a question somebody said. Okay, in the quantitative way, the regression is usually a nice way. Okay, or you can simply do experiment. Experiment is straightforward. This guy will enjoy free SHS, this guy will not enjoy. You put both of them in pre-sec, don't put them in different schools. So you can do experiment without running regression. It's another way of established causality. Give this guy free SHS, don't give this guy. Put them in pre-sec. Give all of them the same amount of Gary and sardine. So you control the experiment, the same amount of homework, everything. At the end of the term, take their scores. You may be able to attribute the difference in performance to the free SHS variable. So that's why the sciences, life is very easy for them. Get money, run the experiment, and you conclude. Okay, so experiment, regression, there are other ways. But causality is heavy, okay, and regression analysis is very heavy. Okay. So, I was saying something before I digress. So you have to read about 20 current papers in your area. When you read it, you will see some of the authors even make suggestions for future research, and you can pick it up and go. But I can promise you, if you haven't read and you are sitting down thinking, even if an idea comes, you go and check Google, somebody has done it, and you'll be frustrated. So take your time, read about 20 papers in your field, or go to your advisor and say, what are you working on? Okay, nowadays I give my ideas to the students and they flesh it out. So you may have a professor or lecturer who doesn't have time. We don't have time, but you people have plenty time. So you just talk to the guy that, oh, you have a project that I can tackle, and then you tackle it. There are plenty. Okay, there are plenty. So that's one way around it. Do we need, Doctor, please, does this imply that we need to establish homogeneity between variables as a way of establishing causality? Yes, you must provide the same environment. You must provide the same environment if you really want to pin down the causality. If you want to pin down, provide the same environment, the same plot of land, put this fertilizer here, put this fertilizer here. Make sure the quality of the soil is the same. You want to gauge the impact of fertilizer. The same plot of land, the same nutrients in the land originally, the same rainfall or irrigation. Otherwise, you contaminate it. You cannot attribute the difference in the harvest to the fertilizer. And next week, you will learn that regression analysis allows you to control for all these things without necessarily going to find the same amount of rainfall, the same amount of irrigation, and so on. So that makes regression powerful. That makes regression powerful. Okay. So going by, any questions? So the ComSA guide, that's what, just read a lot on your own, or because you are computer, it's actually easy because I suspect that guys have plenty projects lying there they don't have time to tackle. And then you will tackle that. One of my research, I went to a website in Washington, D.C. They were looking to employ somebody. Then they say, oh, we want to, the PhD will employ, this is the study we want him to do. So they have already thought about what they need. So when I saw that, I tackled it quickly. Because that is what an industry person is interested, that it should be studied for them. So that's another way. Sometimes you have a data, some data lying down, then you ask yourself, what can I do with this data? Okay, this data has information on NHIS. Are you enrolled in NHIS? Have you refused to renew it? Why? Why? Because the project, the NHIS is not working. It doesn't cover, blah, blah, blah. I have a student who did that. He got the data. So we got the idea from the data. The data says, the data has question about NHIS. And say, okay, what can we do with this data? Looks like they have question on NHIS. Then let's study what? Multinomial logit. What predicts the likelihood of somebody renewing or failing to renew their NHIS membership? So you can have data. Those of you in the waste management, I saw one thesis from you guys about waste, somebody bottle water, those things. You can collect the data and decide what is useful, what can be done with the data. You can visit a lecturer, ask them of their projects that is lying down you want to tackle. But if you want to do something interesting that you'll be happy with you, that you chose yourself, you gotta read 10 to 20 current papers. You will see the trend. what is going on, so that you don't even do something archaic, which people are no more interested in. Today, a Cambridge journal sent me a paper to review and comment. Somebody submitted from Vietnam. And what the guy is doing, the thing, no, it's gone. It's kind of, it's no more exciting. It's no more exciting. But I may tell them to accept if it is good enough. Okay, somebody raised the hand. Go ahead.
Yes, Doc, please, what you are talking about is really what is on my heart. Is why I'm
I'm not going to teach again. I'll use the rest of the class for that. Please.
Yeah, because I feel that is the, you see, you kept reading. I must admit, I've not, the strategy I was using it here, I have something in mind I want to come and do. But what you're saying now, I think makes much sense.
Yeah.
I have to go through the literature and see. But is that our field, for instance, the computing environment, things change so fast and so rapidly.
Yeah.
And I have the fear, as you are saying, you tend to do something and lo and behold, you go and read something, oh, this has already been done. It has. I mean, how do you identify that niche? That's
why I told you it must be 2020 and current, right? If you read something from 2006, that's where you run into trouble. But I bet if you pick a paper from a school in New York, just go to the website, the top computer science schools, look at what the professors are doing. Anything somebody's doing 2020 is current. Yeah, they're on top of issues. So browse the foreign websites. Go University of California, something, Berkeley. Look at the current way the professors are researching. That cannot be archaic. Yes. And so it will lead you to know that, oh, okay, looks like the focus is now on this nanotechnology, AI. The focus is on this. But otherwise, as for computer, you run into that trouble. By the time you do it, it's no more interesting to people and so on. So I encourage you, go to the foreign universities website and see the project the professors are doing. Okay, they are doing a lot of interesting and current stuff. You can send them an email that, hi, professor, I saw this work of yours. There's a guy in England. I saw his work. I emailed him that I will read it and we discuss. Something like that. He may be generous. He can come on Zoom and you discuss. You can send him an email that, please, I'm a graduate student. This part of the research, I don't understand. And they will explain to you what they did there. And then when you read the abstract, you will see that how they motivated it. That, oh, this nowadays, whatever. This, I have a friend working on this. And by the way, there is a Facebook, there is a Facebook fellowship going on. You can check it out and apply. They will, so social media. So my friend is working on how people. Okay, he said when you see people are able to say abua kwasia on Facebook, but when you say stupid, foolish, it can flag you. Okay, when you say foolish, stupid, blah blah blah, and you are insulting your government, they can flag you, even in the United States. Okay, so to go around it, people are using local languages. And then my friend, okay, in the US, is now working on things that around that. I don't want to give out his idea, but so he's saying he has established a gap. People are bypassing the English language and insulting government in their local languages. And the system is not able to pick some of those, blah, 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 blah. So that's how he motivated his work. And I wrote recommendation of that for him last week in the US. So if you actually want to be computer science, you are awesome. You are awesome. You can be here and get a job from there. So just do what you are doing there. Check out the website. Any other question on research? We have about 10 minutes. Any question? Benis, Sadat, Prince, Equia, Alberta. Ameyao, Annette, Araba, Benjamin. But any question? Christabel, Claudius.
Please, Doc, my question is, we were comparing, how do you call it, the regression, simple regression model with the equation of a straight line, which is y equals mc squared, mx plus c.
Yeah.
So my question is, how is it different from the simple regression model? Because that one has another term. That is the u, which is the error something.
Error. So here, so this is a simple regression with an error term. So this looks like y is equal to m. This is the m. X is here.
Yeah.
Plus c.
Yeah.
Yes. So I'm saying that if you were to end it here, I've taken up the u. If you end it here, this is equation of a straight line. This is deterministic. This one means exact relationship. If you tell me your fertilizer, I can predict your yield with certainty. But in real life, there is no exact relationship. So this linear model, linear straight line, deterministic model is not adequate to capture the real life scenario. So we introduce the other variables that affect y that we do not know. So the straight line is not adequate. It suggests that things are now exact. Remember, two people can use the same fertilizer, but they will have different yields. He will say you have lied to him. Then you tell me, yeah, but it's not a straight line deterministic. There's an error stochastic term, which is causing the variability or the probability distribution. Does it make sense?
Yeah, thank you very much.
Yes. So in the statistics department, we usually do free clinics. We will send an email around. You people can come and ask all your questions, and we answer those we can. Probably we will do one. I was the one in charge last time. I'll be moved from there to seminar. So they might do a clinic, and you can come and ask things pertaining to your research.
Thank you very much.
So to formulate your idea as a PhD, that's the problem. Do something smart. Okay, do something smart that, and by the way, put effort in your PhD. Some of you are smart. I have no doubt you will graduate. Okay, that's not an issue. You know how to write exam. You are experts. Graduating is not a big deal. Some of you, when you graduate, you can't even be lecturers here, and that's bad. Any PhD graduate here should be qualified to be a lecturer here. But if you are so busy, you are working in town, you are doing the thing, and you are passing, and you graduate, you will not be well-grounded. You will not be an authority.
Yeah.
You will not, but make sure you are spending 4 years of your life doing something. Make sure you've devoted the time, and you are not hiding when they call you to come and do a simple presentation, talk about your field. And that will come by if you invest adequate time in your thesis. So it is not about graduating, but doing something you like the work you did, and you own it. You did it yourself. You did it yourself. There is a member of parliament I heard, he got a PhD.